friends, this is the eigenvalue and eigenvector. Today we will discuss. This is the lecture number matrix 15. Okay, so how to find the eigenvalue and eigenvector? You must just know that Ax is equal to lambda x, where lambda belong to scalar. Okay, this is the formula to find the eigenvector and eigenvalues. Okay, so this is the formula. So here we are discussing the 3 into 3 matrix. Similarly, after some time I will tell you that if you have 4 into 4 or 5 into 5 or 9 into 9 matrix or n into n matrix, then what will you write? What will be the formula, basic formula? So here we have written lambda cube. Okay, lambda means scalar. Lambda cube minus, then after that minus plus continue. Then trace of the matrix. What is the trace? Trace means sum of the all element at diagonal. Means this is the trace. Okay, this is the diagonal. Okay, this is the trace. 2 plus 3 plus 5. This is the trace. In any matrix, the sum of the all diagonal at sum of the all element at diagonal is called the trace. Okay, so trace of the matrix or principal minor of order 1. I will explain you what is the meaning of principal minor of order 1. Principal minor of order 1 means you have to take the element who are at diagonal. So there are only 3 elements, this element, this element and this element. So take this one, take this one, take this one. Means you have to make a matrix by the help of diagonal, and that is 1 into 1 matrix. Minor of order 1 means take a matrix 1 into 1. Okay, take a matrix 1 into 1 who are at diagonal. So there is only one, that is 2, 3, 5. Then after then principal minor of order 2, I will explain you. Principal minor of order 3, I will explain you. Or determinant of the matrix is equal to 0. That is the basic formula to find the eigenvalues. Okay, so we have taken this example. Okay, by this example I will explain you. So what we have written, lambda cube. Then after then trace of the matrix means 2 plus 3 plus 5. 2 plus 3 plus 5. Then after then we have written lambda square, then plus, principal minor of order 2. Principal minor of order 2 means you have to take any 2 element. You have to take any 2 element who are at diagonal. So that is, at first we are taking 2 and 3. So with respect to 2 and 3, the matrix will be, if you are taking this and this, then the matrix will be 2, 1, 0, 3. Okay, this is the first one. 2, 1, 0, 3. Then now you have to take another 2 element who are at diagonal. Okay, this is 3 and 5. This time we are taking 3 and 5. So this is plus 3 and 5. With respect to 5, this element you will take. With respect to 5, this element you will take. Then you will get 3, 1, 0, 5. This is another one. Then plus. Now this time you have to take 2 and 5. You have to choose only the element who are at a diagonal. So either you will take 2, 3, or you will take 2, 5, or you will take 3, 5. 2, 3, 3, 5 or 2, 5. There is only 3 ways. Okay, 2, 3, 3, 5 and 2, 5. You have to take only 2 elements. There are 3 elements. Okay, there are 3 person ABC. How many ways you can click the photo? The first one is either you will take AB or you will take BC. Either you will take AC. Means you have to take only 2 elements, 2 person at a time. So how many ways you can click the photo? Either you will take AB, BC and AC. So there are only 3 ways. Okay, different pick and different by the help of different person. So similarly, either you will take 2, 3 or 3, 5 or 2, 5. So 2, 3 with respect to this corresponding to 2 and 3. This element will come corresponding 3 and 2. This element will come. Similarly, this and this element will come for 2 and 5. This element and this element will come. Okay, this 0 and 2. Okay, so 2, 2, 2, 2, 2 and 0, 5, 0, 5. That is the, you will find the determinant for everyone. Okay, after then we have taken lambda because of we have taken lambda. Okay, then at last principal minor of order 3. Now this time you have to take 3 elements. At first you took one element, then you took 2 elements at principal diagonal. Now this time you are taking 3 elements at principal diagonal. If you take 3 elements, then the whole matrix will come. Whole matrix will come means determinant of the matrix. So we have taken determinant of the matrix. So at last determinant of the matrix is equal to 0. this whole one is the polynomial. Okay, so now solve it. Lambda cube minus 5, 6, 7, 8, 9, 10. This is 10 lambda square plus solve it. 3 to the 6, 1 minus 1 into 0 is equal to 0 plus 5 3 is 15 plus 15 minus 0 and 2 to the 5 to the 10 minus 0. 5 to the 10 minus 0 into lambda plus determinant of the matrix. So whenever you have this matrix, such type of matrix, triangular matrix, then the determinant of the matrix is the product of the all diagonal element. 5 into 3 into 2. Okay, 2 into 3 into 5. This is the determinant of the matrix is equal to 0. So your polynomial, it will be 10 lambda square plus 31 lambda minus 30 is equal to 0. Now you have this polynomial. Now by the help of this polynomial you have to find what are the lambda, for what lambda it will satisfy. So there are total number of 3 solutions such type of equation, because the order is 3. Okay, so the first one it will be you can just check by the help of this how many factor of this 30. So the factor, just I am taking the factor of 30 is equal to 5 3 there are many factors, just you can take your high school method. So if you just take 2 is also factor of 30. If you take 2 to the 4 to the 8, 2 to the 4 into 40, 2 to the 4 to the 8 minus 40 plus 31 to the 2 and 2, 3 to the 6 and minus 30. Now calculate it. 60, 70, 45, 6, 70. Okay, it is satisfying. It means that if we will divide lambda minus 2 to this one, which one? Lambda cube minus 10 lambda square plus 31 lambda minus 30. Then you will get another solution. So at first you will multiply lambda square to this, then you will get lambda cube minus 2 lambda square. Then after then minus plus, it will be 0, and this is plus actually. Minus 10 plus 2 is equal to 8 minus 8 lambda square. This will come 31 lambda. This is the high school. Again you will multiply by 8 because of minus and lambda. If you multiply lambda this, then you will get the same thing. So this is minus 8 lambda square and minus plus 8 to the 16 lambda. Then after then you will multiply by minus plus minus, then this is 0, but this is 31 minus 16 is equal to, you will get 15 lambda. Okay, this will come minus 30. So now you have to multiply by 15 to this one, then you will get 15 lambda minus 30 answer. So if you multiply this and this, then you will get this. So it implies that your solution is lambda minus 2 lambda square minus 8 lambda plus 15. Now you can use the basic method. Lambda is equal to minus b plus minus under root b square minus 4ac upon 2a. If you have such type of matrix, a lambda square plus b lambda plus c is equal to 0. Okay, this is a high school. If you have such type of equation, then how to find the lambda? This is the basic formula you can use, and you will get lambda minus 2, lambda minus 3 and lambda minus 5. So your eigenvalues are lambda 1 is equal to 2, lambda 2 is equal to 3 and lambda 3 is equal to 5. So these are the 3 eigenvalues of such matrix. Okay, the 3, 2, 3, 5, it will satisfy also this one. That is the Cayley-Hamilton theorem. Okay, just we are not just talking about this time. So these are the way to find the eigenvalues. Now how to find eigenvector? Okay, so this is the formula. A x is equal to lambda x, it will come here. Then after then a minus lambda into I into x is equal to 0. Okay, so you will place this matrix here: 2 1 2 0 3 1 0 0 5. Okay, this is your matrix minus lambda and I is equal to 1 0 0 0 1 0 0 0 1. Okay, so this, then after then x means 3 variable x1 x2 x3. Okay, so because of degree is 3, because of this is 3 into 3 matrix, so 3 vector, there will be 3 vector 0 0 0. Okay, So now suppose we are taking with respect to 2, you will find the first eigenvector. With respect to 3, again you will find the another vector. With respect to 5, again you will find the another vector. So there will be total number of 3 eigenvector corresponding to this eigenvalues. Okay, so first one we are taking lambda 1 is equal to 2. Then you will get 2 1 2 0 3 1 0 0 5 minus 2 1 0 0 0 1 0 0 0 1 into x1 x2 x3 is equal to 0 0 0. Okay, okay, just calculate it. Then you will get 2 minus 2 is equal to 0. Then you are getting this one. 2 minus 2 is equal to 0 0 and 1. This is same 1 or 2. Then after then 0 0 3 minus 2 is equal to 1 1. Then 1 minus 0 is equal to 1. Then 0 0 0 0 5 minus 2 is equal to 3. Okay, so you are getting this one. Okay, then after then x1 x2 x3 is equal to 0 0 0 0 0 0. Now compare. Then you will get multiply this and this. Then you will get x2 plus x3, sorry, x2 plus 2x3. x2 plus 2x3 multiply this. Then after then 0. Then the second one is multiply this and this. Then you will get x2 plus x3 is equal to 0. Multiply this and this. Then you will get 3x3 is equal to 0. So x3 is equal to 0. If you will put x3, then x2 is equal to 0. So we cannot find x1. So x2 is equal to x3 is equal to 0. So if you cannot find x1, it means that you can take x1 is any variable. Suppose we are taking 1. If you cannot find the value x1, so you can take any variable. It means that x1 is linearly independent. So your first eigenvector corresponding to this lambda 1 is equal to 2, you have 1 0 0. This is the eigenvector for lambda is equal to 2. Similarly, now you will put 3 here, 3 here, 3 here, 3 here. After then you will get one solution eigenvector corresponding to this. Similarly, lambda 3 is equal to 5. You will put here 5. Then after then you will get something that will be third eigenvector. Okay, so you must note that whenever you have two eigenvector, then corresponding to two eigenvector you will get two if suppose you have two eigenvalues, you have two into two matrices. So corresponding to two eigenvalues you will get two eigenvector. This time you have three eigenvalues. Corresponding to three eigenvalues you will get three eigenvector. Okay, we have find only one. This is your homework. Put this value here. Then after then you will get another eigenvector. Put this value here. Then you will get another eigenvector. So that different eigenvectors are the eigenvector for this matrix. Okay. Thank you so much.